Welcome to The Explainer. Today, we're going to dig into one of AI's most elegant and honestly kind of clever tools. We're going to uncover what I like to call the secret of the mirror. It's this surprisingly simple idea that lets a machine genuinely understand the data it's looking at.
All right, so here's the game plan. First, we're going to tackle a massive problem that really holds AI back. Then, we'll look at a totally different way of learning. After that, we'll get into the mirror trick and see how it helps machines figure out the hidden structure of, well, reality itself. Okay, first things first, the data bottleneck. Look, we all know an AI is totally useless without data, right? But here's the thing, you can't just dump a bunch of raw information on it and hope for the best. Getting that data into the perfect shape, man, that is one of the biggest headaches in the entire field. So why is getting good data so hard? Well, it all comes down to this process called feature engineering. And let me tell you, this thing is super important for most machine learning systems. But, and this is a big but, it's also ridiculously manual and slow. A lot of the time, it's the single biggest thing slowing down the whole process of building a new AI. Yeah, for ages, if you wanted great results, you had to have human experts, actual people, spending just endless hours handcrafting the perfect set of inputs for an algorithm. They'd be sitting there trying to manually figure out, which little pieces of this data actually matter. This complete reliance on human intuition, it's been a huge bottleneck holding AI back. So obviously, to get past this roadblock, we need something better. We've got to stop, hand-holding our algorithms. We need to figure out a way for them to learn the important stuff all on their own. We need to teach these machines how to teach themselves. And that right there is the whole idea behind something called representation learning. The goal is actually pretty simple when you think about it. Let's build algorithms that can automatically take all this messy, complicated data and turn it into a clean, structured, a representation. The machine figures out what's important all by itself. And don't get me wrong, the ambition here is absolutely massive. I mean, you've got pioneers in the field like Yoshua Bengio basically saying, look, for an AI to really understand the world, it can't just be looking at a bunch of pixels. No way. It has to learn how to identify and, this is the key word, disentangle the hidden factors that make up everything it sees. That's the whole ballgame.
Which finally brings us to the star of our show today, the autoencoder. And when you first see it, you might think it's doing something incredibly simple, almost boring, a kind of mirror trick.
So what is it? Put simply, an autoencoder is just a neural network that's trained to do one job: copy its input to its output. That's it. You give it an image, and its only goal is to spit out that exact same image. Kind of seems pointless, doesn't it? But here's the catch. The magic isn't in what it's doing, but in how we force it to do it. It works in two main parts. First, you've got the encoder. Its job is to take the input data and just squeeze it down, compress it into a tiny little coded version. That's the bottleneck we've been talking about. Then you have the decoder, which takes that tiny code and tries its absolute best to build the original data back up from scratch. All right, so this leads us to the really cool part, the hidden shape of data. Because if making a perfect copy isn't the real goal, what is? Well, all the magic happens in that struggle. The struggle of trying to push all that information through that tiny bottleneck. So think about it. If the network can't just cheat by memorizing the data to make a perfect copy, what on earth is it actually learning? By being forced to rebuild everything from that super compressed code, it has no choice but to learn the deep, essential structure of the data itself. And the secret to understanding this is a really beautiful idea in machine learning called the manifold hypothesis. It basically says that most real-world data, think images of faces or even the sound of someone speaking, it isn't just a random mess of points scattered everywhere in some high-dimensional space. Not at all. Instead, all the meaningful data points tend to clump together along a much simpler, lower-dimensional structure. We call this a manifold. A great way to picture it is like a rolled-up sheet of paper. Even though it exists in our 3D world, all the points on it really just live on a simple 2D surface. And this is where it all clicks. This is the autoencoder's real job. It's not a mirror. It's more like a data sculptor. That bottleneck forces it to just chip away and discard all the useless noise, all that empty space, and learn only the coordinates that exist on this hidden manifold. It absolutely has to find the true underlying shape of the data if it has any chance of building it back. So by learning this underlying shape, the autoencoder starts to figure out which changes to the data are actually meaningful. Just imagine you're standing on that rolled up paper. There are only certain directions you can walk while staying on the paper, right? The autoencoder learns these valid directions of change, the ones that keep the data making sense. In the math world, this is called learning the tangent plane. Okay, let's make this super concrete. Look at this handwritten number 1. A well-trained autoencoder doesn't just memorize this one picture. No, it learns the entire manifold of oneness. It figures out all the subtle ways you can change the image, these little shifts, these slight rotations, while it still, without a doubt, remains a 1. It learns the essence of being a 1. Okay, so learning the hidden shape of the data, that's step 1. Now, for the grand finale, let's see how all this leads back to that ultimate goal we mentioned at the start, untangling the very factors that make up reality. Think about a raw image. It's just a big mess of what we call entangled factors. The value of a single pixel, what does it depend on? Well, the object's shape, the lighting, any shadows, the camera angle, it's all jumbled together. Now, the goal is to get to a state of disentangled factors. And by learning the data's manifold, the autoencoder can do exactly that. It can find the independent causes of variation. It essentially creates separate dials you can turn, one for the object itself, one for the lighting, one for its position. And this is the entire point of representation learning. When you can successfully separate out all these different sources of variation, you can build an AI that is so much more robust. Suddenly, its learned features start to match up with concepts that we humans understand. And that is a massive step towards creating a more general, human-like understanding of the world. So that leaves us with one final, pretty mind-bending thought. That simple mirror trick of the autoencoder, by forcing it to find the hidden shape of data, it hands us an incredibly powerful tool for disentanglement. And you have to realize, this isn't just about making sense of images. This is a foundational step towards building an AI that can actually begin to understand the fundamental underlying factors of reality itself.